Right, we are on study pack 14 towards the last bit of it, where we discussed in the last lesson about the isomerism. We had a detailed discussion about the structural isomers, the isomers which has the same molecular formula but different arrangement of atoms, different structures. That was discussed in the previous lesson. The three types of structural isomers was discussed: the chain isomer, the positional isomer, and the functional group isomer. And the second of isomers are geometric isomers. Geometric isomers arises due to the restricted bond rotation, which is the presence of carbon-carbon bond. And we got two geometric isomers, cis isomer and the trans isomer. So there are two conditions that favors the formation of a geometric isomer. The first condition is the presence of the restricted bond rotation, meaning the carbon-carbon double bond. And the second condition is that each carbon across the carbon-carbon double bond should be attached to different entities. And I say entities, what I mean by entities is atoms or group of atoms. Atoms or group of atoms, right? So if the similar groups are on the same side, we call it as cis. If the opposite side, we call it as the trans isomer. And then I think there where we stopped, I explained about the cis-trans isomers. I think we named the cis-trans isomers of these molecules here. And today, to continue from page 22 onwards, the cis-trans geometric isomerism in cyclic compounds. Now, like alkenes, this type of geometrical cis-trans isomerism, which is a part of stereoisomerism. I said isomerism is of two types, right? Stereo and geometric isomers. I mean, stereoisomers and the structural isomers. Structural isomers of three types: chain, positional, and functional group. And then you have the stereoisomers. Stereoisomers of two types: optical and geometrical. So we are in geometric isomerism still. So let's see how cyclic compounds show geometric isomerism. So cyclic compounds does not have it's not a condition to have carbon-carbon double bond. The cyclic nature itself gives the restricted bond rotation, right? So cycloalkane, especially, no need to be a cycloalkene. A cycloalkane has two distinct phases. Now, if you take, if you analyze a 3D form of this, if you analyze 3D form, you have the top phase, that's the top part of it. It's imagined in the 3D form, and you have the bottom phase, right? So any group other than the main carbon ring, other groups face either the top phase, top part of it, or the bottom phase, right? So substituents in a ring cyclic compound faces either the top phase or the bottom phase, right? So if the substituents are on either the phase, on the same side, for example, they're next to each other like adjacent carbons. If they are, in this case, you can see the CH3 groups are the similar groups. If they are next to each other in one phase, we call it as cis. But if they are in opposite phase but next to each other, in this case, we call it as the trans, right? So because this ring act as a carbon-carbon double bond. It's like a carbon-carbon double bond, even though there's no carbon-carbon double bond, but the ring gives the same condition as the restricted bond rotation in a carbon-carbon, right? So if the similar groups are in the same phase, we call it as cis, and if they are on the opposite phase, we call it as the trans. So you can represent these structures in a 3D form in skeletal structure this way. Cis, you can see both of these groups, CH3 groups, are coming out, right? This triangle means coming out. So we are looking at a different angle now. And here you can see one is coming out, the other one is going in. So this is both are coming out here towards the not away from us, towards us. So it is cis, and one is going away from us, and then one is towards us. So it is trans, right? So that is how the cis-trans isomerism is found in cyclic compounds. So before we start the optical isomers, let's draw the cis-trans isomer structures of these compounds in a 3D geometrical form, right? I say 3D geometrical form. What I mean by this form, right? Not like this. You can draw like this also, but here I'm expecting you to draw the 3D, the geometrical form like this. So let's draw 1,3 dimethyl cyclohexane. So cyclohexane is like this. This is cyclohexane. So 1 and 3. First carbon and the third carbon has the methyl group. So, right, if both are coming out, methyl groups, nothing to show here. There's no atoms. So I'm going to show like just like a triangle. The line represents carbon here because this is skeletal formula. This is both are 1 and the third, both coming out, right? This is 1,3 dimethyl cyclohexane. This is cis form of it. And then you have trans form. First one and the third one. One is coming out top face, and the other one goes in. You can put a line, dotted line. Sorry, this is just a carbon here. So this dotted line, or you can even show this way. That's also fine. This is trans. Okay. So I had done the first one, copy it, and we can try the rest. Let me know once you're done. Next one, 1,2-dibromo cyclopentane. So cyclopentane, 1 and 2-dibromo. So you can put both the bromines, 1 and 2. Any carbon can be named as first carbon, The other one is going in. This is the trans. And both coming out, or it can be both going in. both coming out or both going in is cis. Try the others, please. Right, so the next one, 1,3-dichlorocyclobutane. Cyclobutane. 1, 3. 1, 2, 3. Dichloro. So both coming out or going in is cis. And one is coming out, the other one goes in, that is trans. Try the other three, please. Three-methyl cyclopentanol. Cyclopentanol, so the OH group, and third carbon has a methyl group. So this is like you have the methyl group and the OH group. So it is you can take as cis, even though they are different groups. But generally we get similar groups. But if it's different, this is how we can name it. And if one comes out and the other one goes in, then that is trans. Even though they are different groups. Have cyclobutane, 1,3-dioic acid. Trans. One, 3. This is cis. Right, the last one, done. We can also draw the cis the other way, which means both goes in like this. This is also cis. Either both comes out or goes in. And at last you have 1 bromo, 2 chlorobutane, cyclopentane. 1 bromo, 2 chloro. Both goes in or comes out. Yes, cis. 1 comes out, 1 goes in, and the other one comes out. It is trans. Please check your answers. Any questions? Any clarifications before we start the other type of stereoisomer, which is the optical isomer? Let me know if you have any questions. Let's move on to the next type of stereoisomer, which is the optical isomer. Before I start on optical isomerism, let me explain to you the meanings of the term superimposable and non-superimposable. If you can keep structure on top of the other structure, we say those structures are superimposable, right? For example,